The S202 fine locator consists of two units, the acoustic transducer or pickup and the amplifier unit with headphones. It is supplied complete in a strong, lightweight transit case. The case is foam lined with cutout positions for each component. The S202 fine locator is an easy to use dual channel detector and amplifier specially designed to determine the precise position of faults on underground cables in conjunction with a surge generator or capacitor discharge set. The instrument is used to locate cable faults by pinpointing the seismic disturbance created by the energy from a surge generator arcing over at the fault, either between conductor and cable sheath or between two conductors. A sensitive pickup detects this seismic disturbance, which is then amplified and indicated to the operator both audibly on headphones and visually on a display meter. In addition, the instrument incorporates a magnetic detector with separate amplifier to pick up and display on a separate meter the change in the magnetic field caused by each current impulse from the surge generator. This feature greatly assists in identifying the acoustic fault signal and differentiating it from the background noise. When an acoustic signal is indicated coincident with a visual signal from the magnetic detector, the position of maximum acoustic signal may then be determined to pinpoint the fault position. The acoustic transducer converts the vibration or seismic disturbance created at the fault into an electrical signal. The transducer comprises a moving coil mounted in a magnetic circuit contained in an inner screened case to eliminate pickup from any external electromagnetic interference. A waterproof outer housing also provides further efficient screening. An extension handle is provided which may be screwed onto the top of the case to facilitate moving and placing the transducer. The amplifier unit consists of a plastic housing which contains both the acoustic and magnetic amplifiers, the magnetic detector and the battery supply. It is fitted with a metal top plate on which are mounted the controls, display meters and connecting sockets for the acoustic pickup and the headphones. The acoustic and magnetic amplifiers are contained within separate screened compartments to prevent cross-coupling, and a separate battery for each amplifier further reduces the possibility of the signal from one channel affecting the other. The controls of the unit are as follows. Pickup socket. This is a 6-pin DIN socket for connection of the acoustic transducer to the amplifier unit. Inserting this plug switches the amplifier unit on. Note the orientation of the plug when inserting. Headphone socket. This is a 5-pin DIN socket for connection of the headphones to the amplifier unit. Again, be aware of the orientation of the plug. Battery test button. This red push button switch is for checking the condition of the batteries as indicated on the associated meter. The gain control. There are two of these, one for each amplifier. Rotate clockwise to increase gain. Display meters. Two output display meters scaled 0 to 10. One for the acoustic channel, the other for the magnetic channel as marked. These give a proportional signal level indication for their respective channels. Mute button. Black push button switch disables headphones when pressed, i.e. no acoustic signal to the headphones while depressed. This switch enables the acoustic pickup to be moved for signal comparison purposes without adjusting the gain control, thus removing the discomfort of loud acoustic signals on the headphones when gain is high. And onto the operation of the unit. Remove the acoustic transducer, amplifier unit and headphones from the carry case. Install the extension handle to the acoustic transducer and attach the neck strap to the amplifier unit. Instrument check. Check the battery condition for each amplifier. Depress the battery test push button switch and check that the deflection on each meter is above 5 on the meter scale. If either meter gives a reading below 5, then replace the appropriate battery. Connect the acoustic pickup to the amplifier unit. This switches the amplifier unit on. Connect the headphones to the amplifier unit. Pay close attention to the orientation of the plugs and sockets. Rotate the magnetic channel gain control clockwise to its maximum position. the magnetic detector will now be in its most sensitive condition to pick up the magnetic signals from a pulsed cable. The control may be left in this position until signals are picked up from the cable under test, and may be then adjusted until an adequate deflection is obtained on the magnetic channel meter. Note that the magnetic detector is mounted longitudinally within the base of the amplifier housing. The optimum position, therefore, for maximum signal detection is when the amplifier unit is horizontal, directly above the cable, and orientated so that its length is at right angles to the cable route. Set the acoustic pickup on the ground and rotate the acoustic channel gain control clockwise to increase sensitivity. Acoustic signals are now picked up which are audible on the headphones and displayed on the acoustic channel meter. Tap the ground in the vicinity of the pickup to give identifiable signals. Check that the mute switch functions whilst pressed. With the exception of short lengths of cable, it is normal practice to carry out a preliminary fault location from the cable terminations by one of the standard pre-location methods to determine the appropriate position of the fault and thus the search area. This area is then investigated with the S202 phone locator and the precise position of the fault is pinpointed. Set your surge generator to discharge into the fault conductor at regular intervals, say 3 to 5 seconds. The voltage and capacitance selected will depend on the rated voltage of the cable and the fault characteristics, but for best results, the highest values practicable should be used. Investigate the suspected fault area of the cable route with the seismophone, orientating the amplifier unit for maximum magnetic signal as already described. Vary the magnetic gain until a satisfactory deflection is obtained on the meter. By traversing the cable route and determining the position of maximum signal, the exact line of the cable may be found. The minimum sensitivity necessary to give an adequate signal should now be used in order to keep the detector over the cable. Search the suspected fault area using the acoustic pickup with sufficient gain until the acoustic signal from the fault is detected. This is identified by being repeatedly coincident with the magnetic signal. Using the gain control, the position of maximum acoustic signal may now be determined and hence the position of the fault. As small changes in signal level may not be recognised on the headphones, it is preferable to use the meter for this determination. The acoustic pickup should be placed on the ground and not held, since small movements of the pickup will generate noise.